we're considering a transformation of a function here, multiple transformations of the square root function. It's been reflected in the x-axis because it's multiplied by a negative. It's been vertically stretched by a factor of 2. It's been moved over to the right 3 units, and it's been moved up 1 unit. So what I'm going to do is identify what A, B, and C are. A is what the function is multiplied by, and that's negative 2. B is whatever happens to the x before the function is completed. So what's done to the x is you've subtracted 3. And C is what's done to the whole multiple of the function when it's finished, and that's the plus 1. All right. Now, these all have the effect of changing points on the functions. So it's useful if we know what the square root function looks like. And here it is. The regular square root function, I've chosen x's that are perfect squares, so I get nice rational quantities for y. So my key points for square root function are 0, 0, 1, 1, 4, 2, and 9, 3. The domain and the range are greater than or equal to 0, and my function's constantly increasing along that domain from 0 to infinity. This is what the graph looks like. It's increasing but fairly slow. Excuse me, slowly. Okay. All right, so now we're going to figure out what's happened to these key points. So I like to start with my parent function key points. Parent function is the plain old square root of x. So square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3, just like I had there. Okay, what's happened to it? All right, the only effect on the x-coordinate has been your b. B has the effect of moving the graph 3 units to the right. So what that does is you subtract b from all the x coordinates. Now in this case you subtract negative 3, so what you're actually doing is adding 3 to all the x coordinates. So that 0 point becomes 3, the 1 point becomes 4, 4 point becomes 7, and the 9 point becomes 12. Alright, y is affected by O and by C. The y coordinates are multiplied by A and C is added. So in this case, I multiply by negative 2 and add 1. 0 times negative 2 is 0, plus 1 is 1. 1 times negative 2 is negative 2, plus 1 is negative 1. 2 times negative 2 is negative 4, plus 1 is negative 3. And 3 times negative 2 is negative 6, plus 1 is negative 5. So let's plot those points and draw the graph. All right, plot the points. 3, 1, 4, negative 1, 7, negative 3, and 12, I'm going to have to add it, negative 5. Here. So this is how my graph goes. All right, I can see that the beginning has changed from 0, 0 to 3, 1. Here's 3, 1. Normally, with a square root function, I go over 1 and up 1. Here, I go over 1 and down 2. That's because of the negative 2. And that's how we do this this transformation. I could ask you domain. Domain is x is greater than or equal to 3. Range, y is less than or equal to 1. It's constantly decreasing. And I could also ask you what's happened to the graph, and you can say reflected in the x-axis, vertically stretched by a factor of 2, translated 3 units to the right, and translated up 1 unit.